Really excited to talk about the visibility work that we do at Heroku. So as Joe was alluding to, Heroku is very briefly, is a platform as a service, which basically means we run apps on behalf of our users. And as Joe was alluding to, there are a lot of those apps. And furthermore, just to provide some context, we run those apps with our own software, which we construct in terms of apps, and that in turn depends on services, and eventually that bottoms out at infrastructure primitives provided by, say, AWS. The upshot of all of that is that we have a huge amount of software running in production, both ours and our users. And given the scale and the scope that we have, we face a lot of operational challenges around that. So our visibility work is largely about understanding and responding to those operational incidents. And these are just a handful of things that we see all the time in production at Heroku. And being able to respond effectively to these is key. Now, by default, and the state that we were in, say, 12 or 18 months ago is this, which is you have no idea what's going on. And if you've ever been in a production situation where you see a 500, but you don't know what's wrong, you know how terrifying that can be. What we're trying to do with visibility is turn that into this, which is taking that issue and shedding some light on what exactly is going on, which one of these is the problems, how that's bubbling up to user code, and so on. And like I said, we call this work at Heroku visibility. It encompasses the whole space of metrics, logging, alerting, and so on. We have quite a bit of software at Heroku around this now. It's one of my particular focuses, and it's an area that we have to make a continuous investment in because of our growing scope and scale. So what I'd like to do today is come at this from a few different angles. First, talk a little bit about some of the specific tools and services we use at Heroku, both open source and developed in-house, and also third-party. Then maybe take a step back and see how those fit together in terms of the overall visibility pipeline that we maintain in terms of data and alerting, and then carry that into kind of our philosophy and approach at the highest level with respect to visibility. And finally, I'll take all of that and use it to show a specific example from production that we had yesterday morning, and how that played out in terms of our visibility services. So tools and services. Start with a really simple one. This is pretty classic and one that I suspect many of you are familiar with, Graphite. We use Graphite for two pretty separate things, although Graphite unfortunately kind of conflates them. One is metric storage and one is long-term graphs. So very quickly, Graphite provides basic hierarchical storage for normalized metrics data. We throw a lot of metrics at Graphite, although not so much that we can't handle it all with one big Graphite server. And Graphite provides a kind of sort of, if you squint your eyes enough, a network service API for storing and retrieving metrics. That's storing and that's retrieval. We'll come back to that in a bit. And then, of course, Graphite provides basic long-term historical graphing of the metrics that are in its database. This is a sort of primitive that, as you'll see, we compose in different ways later on with other tools. So Graphite, this is kind of a vanilla one. It's open source. It's very well understood. It's where we started with our visibility efforts in some ways, but we've had to grow a kind of whole ecosystem around this basic service. So one that we found particularly useful is called Tassio. This was written by a Heroku engineer, Jason. And this has a particular focus on real-time and real-time context around metrics. So one of the problems we face in production is when we have an issue, we have potentially thousands or tens of thousands of users whose own production sites are affected by our problems. So we need to respond to them as quickly as possible. At the same time, our software is like hugely multidimensional. There are a bunch of internal services. They're all interacting in potentially complex ways. And when you stack that up in the cloud, you get potentially some pretty crazy stuff. So what Tassio does is it provides on a web page a really quick and easy heads-up real-time dashboard for metrics that we care about. So typically, these are spans of, this is over the last 5 minutes, and these will update a pixel every, say, 3 seconds and tick along. And so when we're thinking about an area of our platform, this is the top-level view, we can go to this page and see in real time how stuff is evolving, which is great just for an ambient awareness. We have this on a Plasma in our office. And also when you're responding to an incident and you change something and you see one of these graphs do that or that in real time is pretty powerful. Also, this app has an entirely sane configuration mechanism, which is kind of unusual in the metric space, and that you just specify with data what you'd like to appear on the dashboard, and that's what you get. This has an interesting side effect of encouraging engineers to deploy a lot of dashboards. Because this just runs as a Heroku app, we have all kinds of dashboards running on this in production. This is just a sampling of some for our packaging and runtime infrastructure, respectively. And I mentioned the idea of context. This is an incredibly powerful feature that we use all the time in production. When you're responding to an issue, it's great to be able to see what's happening right now. But often to be able to truly understand what's going on, you need the context of how has this been evolving recently. And when I went to do these slides, I went directly to this page and I clicked 3 hours. And there was actually a great example there, which is at the time we had this creeping case over the past 3 hours of these two metrics escalating at the same time. And this one is actually problematic. So by having that context, you're able to see how have these things been evolving in relation to each other over time. When we're responding to an incident, we often come to a dashboard like this and click in between 5 minutes, 1 hour, 3 hour to see how these values stack up. So this guy is open source. You can find him on GitHub, and you can deploy it as a Heroku app in like 2 minutes. There's instructions in the README for how to do that. And again, it pulls from Graphite. So if you already use that as a backend, this is something that you basically get for free. There's really no reason not to use it. OK, so we talked a little bit about metrics, metric storage, and graphing. It's great when you know that you have a problem to go to a dashboard and see, OK, what exactly is wrong. But you can't always be looking at your dashboard. So that's why you need monitoring. And we have a specific goal with monitoring, which is to tie our alerting to those metrics themselves, so that when we get alerted on some quantity, we can go back to all those graphs with the same root data source and respond to the incident. So we have a small tool called Umpire that facilitates this. We call it quality of service monitoring. And all this does is you have this underlying data in Graphite. This is pulling out one specific example. And you say, I'm going to draw a line here. And when the data crosses this threshold, I want to be paged. So in this case, we're saying at 95% availability, this is measuring availability on a scale of 0 to 100, I want to receive a page. And what Umpire does to facilitate this is it provides an HTTP interface that accepts requests, reaches back to Graphite on the basis of the parameterization of the requests, and then returns 200 or 500, depending on how your metric stacks up against the maximum or minimum that you specified. So here, for example, it's over our max, so we throw a 500. And then the upshot of that is that you can plug in any sort of normalized monitoring tool against that endpoint, like Nagios or Pingdom or whatever. And then when you get an alert, you see what the actual failing value was, and you have the ability to go back into that context and revisit it. We use this quality of service monitoring for all kinds of stuff at Heroku. There's the basic stuff like requests per second, errors per minute, also latencies, and even increasingly business metrics. So we say there shouldn't be more than X free apps running on the platform, or there shouldn't be more than Y processes of this shape running on the platform. And if that's ever violated, we can get an alert and then go see the context. Also open source if you want to try it out. Again, easy to deploy to Heroku. Really quickly, I mentioned the idea of pinging this Umpire service. We use Nagios for this. I'm sure there's a good chance you've already seen this. We use it in a very narrow way, which is just checking to see if stuff is alive. All the sophisticated logic is pushed back into other apps. So we talked about Graphite storage a little bit. We throw a lot of stuff at Graphite, but this is not an acceptable input format for us for a variety of reasons. We very strongly prefer to use HTTP interfaces. We have a huge amount of infrastructure around HTTP in the form of routing and visibility and logging and so on. So a simple app that we threw in front of Graphite, inspired by the Librado API, which allows us to submit in an HTTPS authorized way our metrics data. Guy's also open source if you want to check them out. I'm going to plow through this a little bit. So now we get into some stuff that's a little bit more maybe novel and starts to touch at some of the things that we do at Heroku that are perhaps philosophically unusual. So this first app is called ExpressionD, and is a sort of generalization of the idea that was implemented in statsd, which is you have a kind of high fidelity data stream coming into a service, and you sample it or aggregate it or run a computation on it over some interval, and then you emit some rolled up metric to a metric service like Graphite. So we've written this tool called ExpressionD, which is a sort of generalization of that idea, and that applies it to arbitrary log streams. So internally at Heroku, we have all of our apps log in a way that treats logs as data. So instead of having text logs that are in a file, we have a more abstract notion of normalized data that can be interpreted by any machine. And then ExpressionD is an application that can roll this up in potentially arbitrary ways that you can declare dynamically. So this is an example of some data that might be emitted from an app that's checking our HTTP service. It's saying, like, I'm the Canary app. I'm checking the Cedar stack at this URL. It resolved to this IP. This is how long it took, and this was the state. So that's the kind of full fidelity information that's coming out of the log stream for the app. ExpressionD then allows you to dynamically roll that up in different ways. So here, for example, we're saying create a metric within this service, ExpressionD, that allows me to roll up into 99th percentiles over 60-second windows for events that match that description. So when ExpressionD receives that request from the client, ExpressionC, he will look at all the events that come in, look for those that match the pattern we specified, which is successful requests, pull out the value that we specified, which was the elapsed time, and then over that window of 60 seconds, compute whatever the aggregation was we specified, in this case, the 99th percentile. And this guy will just post back to that backstop app we saw earlier, and eventually will end up in Graphite. The reason we developed ExpressionD is because we use, as you'll see, events and logs as our kind of canonical and in some cases only data stores. And we have a lot of quantities that we want to know about that are global to our distributed infrastructure. So we can't compute any of these on any individual nodes. They need the entire log stream to be able to be computed. So some of these are pretty straightforward. Some of these are more involved. Like these guys compute quantities across the last values as seen on multiple instances within the platform. This guy is not open source yet. We're working on it, although there's no reason in particular that it couldn't be also deployed as a Heroku app that we use internally. Really quickly wanted to talk about Splunk, maybe not so much in terms of the commercial product itself, but like why it fits with the approach that we take to visibility. And again, we treat internally all of our log data as logs as data oriented. So they're in this normalized form. They're not necessarily in JSON. The format doesn't particularly matter, but they are essentially key value pairs. And what we use Splunk for then is doing these interactive searches and aggregations and sortings across potentially terabytes of data that we emit from the platform over the course of, say, a few weeks. And again, this is facilitated specifically by having that structured data. So for example, here we're saying, look at all of our data, find events that match these key value pairs with particularly high elapsed times, and then compute, pick out the instance IDs that have the highest frequency in those events. These are some other examples that I'll skip. But the basic idea there is that we use Splunk extensively because it supports data-oriented events. It can do pretty sophisticated aggregations across those. All right, so that's a look at some of the tools and services we use internally. Happy to answer more questions at the end if you have any. I think that rolls then in nicely into our overall pipeline and approach for visibility. So the most important idea for us is that we have a composed visibility pipeline. The historical situation with metrics and visibility has been you have a monolithic thing which is responsible for a specific vertical in your stack, like instance level metrics or business level metrics or service level metrics. And you get all of these silos all over the place that are neither composable nor general. So what we're trying to do at Heroku is build a composed general purpose visibility pipeline in the Unix style. So this is a rough schematic of what it might look like. You have events/logs, structured logs, as the root of the visibility tree, if you will, and that's pushed out into various services. I covered almost all of these, but kind of notably, metrics go through or originate from logs. So logs are the root of all of our data, and they're processed and downsampled as they get pushed outward and eventually visualized over in this tier. And that's important not only because you now have general purpose composable tools, but because your visibility story is coherent. And what I mean by that is that like all of these and whatever they do relates to the same visibility data tree. So for example, via logs. So for example, if I get an alert about my infrastructure, about some particular value that's misbehaving, I know that that corresponds to the same root data as my long-term metric source, and even the ad hoc queries that I can run against our structured data. So being able to use all of these visibility tools against all of the data in the platform has proven really important for us. I talked about this several times now, but I think it's worth calling out specifically. Logs as data is maybe the most important philosophical aspect of our approach to visibility. It's totally critical for everything that we do, and our entire tool chain basically falls out of it. So a classic way to like log, say, a web request is something like this, where you have a log that's treated as a string, meant to be human readable, and it's ad hoc. As we were seeing, it's really important for us to be able to interpret these in various programs that live around the visibility chain. So instead of emitting logs as text, we emit them as data. And there are different ways you can do that in practice, including like key equals value pairs and JSON. And the details aren't necessarily that important for this. But the idea that your logs are data and not strings is critical. That's what allows us to roll up into metrics as we push outwards. Another thing that we try to apply as much as possible is treating logs as truth. One way to look at logs is like they're files that are annoying and they're on your file system and they overflow and you have to rotate them and stuff. Another way to look at them is they're a stream of everything that's happening in your infrastructure and everything that ever did happen. So in that respect, they're potentially quite powerful. And you need correspondingly powerful tools to be able to extract all that information. And you don't want to. You have certain canonical data that, of course, will reside in like a database. But having a sort of a full fidelity view of your entire infrastructure in a single log stream is pretty powerful and general. And this log-based approach also allows us to really importantly, to this point of silos, separate these different tiers. So it's very common to see visibility systems in which like you have a plugin to your app in a specific language that connects to a specific visibility service, which is then presented in a specific way. That works great for that particular vertical, but then what happens is none of those individual pieces end up developing into really powerful tools. So by separating these, we're able to like improve on these independently and kind of plug and remove different pieces over time. And the way I kind of sell this to engineers at Heroku is think about Unix for visibility. We want to have small, sharp tools that we can compose for our visibility tool chain. All right, so those were the tools and services that we use at Heroku, and also the kind of overall pipeline and philosophy. I want to see how this applies to a specific example that we had in production yesterday night / early morning. And I call this visibility-driven incident response. It's very easy to get an alert about something being wrong and then not knowing what to do about it. The goal of visibility, again, is to be able to know specifically what happened and how to respond. So you can see this on status.heroku.com. There was a minor HTTP routing issue in which we had a partial service degradation yesterday morning. And the way we noticed this was because we have a huge fleet of Canary apps running in production that are continuously being checked by our own processes, which emit this data about how those checks are faring. And we have a corresponding metric being computed by ExpressionD, which, among other things, calculates the availability percentage for different slices of our HTTP stack. This is what that availability looked like for this particular slice over the course of that morning, which I know because I can go back and graphite and look at it. And we had a particular threshold for this slice that caused an engineer, me, to be paged when I hit this point, 95% availability for for a few checks. got this page. And you can see Umpire being referenced there, which is the quality of service monitoring tool. And then as soon as I got that page, I was able to pull up our dashboard, which has that metric I was paged about and a whole series of related metrics, and see how the situation was evolving in real time. Sometimes it happens that the error recovers itself, and you see, when you log in, you see like a dip here, and then it's back up to 100%. Sometimes you log in, and it's like getting steadily worse. But the point is, I was responding to this page. I was able to come to this dashboard and see in real time how that situation was evolving and how adjacent metrics like latency of the same stack was changing. Was also able to look at, to help identify the problem, how different HTTP stacks we have compared. So here, it was indeed the case that this particular slice was having trouble. As you can see, it's much more depressed in terms of availability. And as we tried to dig into this issue, we had to go to our data-oriented logs to figure out what exactly the problem was. We pulled out 100 specific examples of errors from these HTTP requests. We saw that there was a pattern with IPs. We were able to graph that over time and see, oh yeah, OK, there's definitely an issue here with one of these particular IPs that our HTTP stack resolves to. And over time, we were able to use that to address the issue. And then post hoc, we were able to go in and see, OK, we need to understand what the root cause of this, pulled out a much bigger timeline, and we're able to see, oh, OK, if we go way back here, way before the incident actually manifested to users, there was this increase in this particular metric, and this is when we resolved it. And now we're able to take this data back and say, OK, we should draw a line here now over time so that if this ever happens again, we get paged. So that was a look at some of the work we do around visibility at Heroku. These are some of those key areas. I want to particularly thank the entire platform engineering team. This is the work of everyone there, and especially Jason, whose work you saw in several places throughout this talk. I'm happy to take any questions. Yes?
How many people are on the platform engineering team that built all this and maintains all this?
So the platform team is, sure. The question was how many people are on the platform engineering team. The platform engineering team it varies. It's like order a dozen people. There's maybe one or two full-time equivalent being working on visibility. So like maybe Jason and myself, I spend a solid chunk of our time on this. But one of the reasons we specifically have to pursue very general tools is that we have order 100 internal services and like order 10 languages and frameworks running on order thousands of machines. If we had to write a visibility toolchain for any one of those dimensions, we'd be hosed. So it has to be very general. That's why we're able to run this infrastructure with so few people.
When you implement your Unix-like monitoring tools, how do you ensure that your monitoring doesn't load the machine too much? I've seen that before. People just make a portrait. Like when I saw the word like awk or
right.
I'm like grep. I'm like, oh.
Yeah.
You don't use those tools, right?
No. So one of the things that we specifically do is this goes back to the point of the question was how do you prevent your monitoring tools from loading up your own infrastructure, from causing load on your own infra? The way we solve that is to not run it on the same machines. So we try as much as possible to construct these things as network services. So they end up potentially loading the network. But if you downsample enough through the tree, it's not that big of a problem. So you can potentially hose your log processor if you send it too much logs, but that's specifically separated from the app. Joe?
How long do you keep your logs for, and what's the rough size of that time frame? Like in this?
Yeah. So one thing that we can do, you saw that the question was how long do we keep our logs for? This guy's dead. I was going to go to the tree. But the answer is we keep the data for different amounts of time for different nodes of the tree. So you saw one node, which was S3 archive, which we keep for order of months. And that's many terabytes. It's massive. Some stuff, like the buffer for the ExpressionD aggregation tool, is like order potentially minutes or hours. And the web page buffers data for order 5 minutes. So it depends on how, which tool you're talking about. We try to keep the the logs for as long as possible because they're the root data. You could potentially pull it back into anything else if you really needed to. Does that answer your question?
Oh, yeah.
Yeah.
Do you have the same visibility into customer information? Because I know that on Heroku, I want to do those same things for apps I run.
Right.
Do you give customers that access?
So the question was, do we have this visibility for customer apps / can they get it? The answer to that question is fascinating because we run most of this on Heroku itself. Like we run most of Heroku on Heroku, so we have to have the visibility to be able to do our jobs. And because most of this data comes from log streams, and you can tap your log streams with Logplex, you could potentially do this yourself. What's missing is, I think, like productization around that right now. Now, for example, ExpressionD is an open source, and something like Splunk is non-trivial to set up. But increasingly, we're seeing more visibility tools that are being built in the form of Heroku add-ons add X, where X attaches a log drain, and you get a dashboard of cool stuff. So it's definitely in the pipeline. It's still early.
Is there any part of your visibility process that's still primarily manual, or is it all automated, or in the process of being automated?
The question was, are there aspects of our visibility process which are manual? Yeah, sure. So one thing that's manual right now is setting the threshold for metrics. It's entirely possible to envision a world in which those are automatically calculated and evolved over time. So we have this thing where like every few weeks, OK, platform traffic has increased. I need to increase this metric. That could potentially be handled automatically. Likewise, we do a fair amount of manual. When we do the drill downs with Splunk or a similar tool, we generate those queries manually.
Okay. And that's done on a case-by-case basis.
Right.
Something looks suspicious, I'm going to investigate.
Right.
So you can't automate everything. There still needs to be intelligence,
Right.
human intelligence behind that.
Right.
What about the configuration of the nodes? Do you use something like Puppet for management of that?
So the question was, what do we do for the configuration of the nodes? The answer is yes, we use a tool, we use Chef. But our approach to that is similar to our one with visibility, which is we have so many nodes. If we had to write a Chef recipe for every one, we'd be hosed. So what we really have is, in the same way that on Heroku, if you want to run an app, it's like Java or Ruby or Node, it's basically the same. Get push Heroku master. We have a similar setup for our internal apps, whereby if you conform to a sane application interface, you get a bunch of stuff for free, including your logs being drained to the Logplex, which you can then shuttle to a visibility service. All right, thanks, guys.